This is a series of videos showing how analytics can be used to disrupt traditional telecommunication operators' processes. Today's video is Automatic Root Cause Analysis for Customer Experience Degradation. Let's see the problem. One of the most important issues for telecom operators is that growing complexity of the networks and the diffusion of over-the-top services has increased the time required to identify the root cause of a service failure. The consequence are additional operational costs and the decrease of customer experience. To face this challenge, operators must find more efficient way to determine the most probable cause when a service KPI goes below its threshold. To answer this question, the first step is to understand how these KPI are created. Quality of experience KPIs are created by network and device information. This data passes through several aggregations and transformations before being loaded in the data model from which KPIs are visualized. KPIs are defined for each main operator's service, voice call, video streaming, social networking, etc. The most common KPIs are accessibility, retainability, and integrity. Accessibility measures if customers can access the service. For example, video accessibility rate or video access time. Retainability measures if customers can get the whole service. For example, video drop or failure rate. Integrity measures if customers get the service with good quality. For example, video freeze rate or video quality level or number of frame per second. When a service KPI is violated, the process to identify the root cause of the violation is the exact opposite of the creation process. KPIs are drilled down or iteratively disaggregated in their subcomponents. Selecting a specific KPI's component, operators can see the trend of this components over a given time frame. The scope of the drill down process is to move deeper into a hierarchy of data, from high-level information to more detailed, focused information, to find the data anomaly. The drill down process can be iterated to analyze the whole data hierarchy of the KPI. The problem with drill down analysis is that it works well if the KPI's problem is due to a single effects only. If the QoE violation is due to the combination of two or more effects, this technique is not very efficient. To avoid the limits of the drill down analysis, we need techniques capable to perform automatic, parallel analysis across all the services degradation components. Machine learning technique and in particular the association analysis can be the right solution as they can perform automatic multidimensional analysis. They can be used to automatically discover the most common elements of fault events related to the service KPI violation. Let's see how the solution works. Step 1. All the events related to the KPI degradation are extracted to be analyzed. Each event record contains information such fault type, device characteristics, location, roaming status, network information, etc. This information is called event attributes. Step 2. These events are analyzed by the association engine to identify the most important association rules or patterns across the event's attributes. An association rule describes a situation like, when an event contains the attribute B then the event contains also the attributes D. This means that an association rule describes the correlation between a specific fault and its most common attributes. In other words, the most common attributes are the most probable cause for such fault. The efficiency of the fault root cause analysis engine can be improved by adding other analysis to the model, for example, event clustering. It is used to group events by similarity. It improves the efficiency of the association engine in discovering relevant rules. Decision trees, they are used to improve the rule selection. Event record enrichments with other correlated information coming from other source. This allow to include in the root cause analysis attributed from other domains, for example network faults or power cell level.